example, you have forces on inclined surface with hinge. Some part vertical, wall, and some part inclined. The gate is, of course, inclined, but you have wall on the other side. So the gate is 3 meter wide. You have 3 meter into the board, which is this dimension. This is the gate. Then just hinged at point B and rests against a smooth wall at A. The gate is inclined with theta from horizontal and with dimensions as shown below. Determine the total hydrostatic force acting on the gate and the position of the center of pressure. What force P is needed to just open the gate? What force P is required to open the gate? So the hinge is nothing, just it is free to rotate, but it does not support the moment. But you have the force, it can carry force, just horizontal and vertical force. So I think what forces P is required just to open the gate and determine the horizontal force Fh exerted by the wall at A and the reactions at the hinge B. If there is no P force, what will happen? So this is geometry. You have this is just the geometry of the gate. You have 15 meter total depth up to the bed of the channel. Then you have wall here. You have gates, and then you have gate dimension. You have total AB distance. You will compute. You don't know this. You don't know this. Then you will compute. So what will be the distance of AB? So you have 3 meter, just the width of the gate into the slide. Then you have theta here. Then you can compute theta. Theta is just tan inverse of 1.5 over 2. And then you can find AB. Just AB is by Pythagoras theorem. You can find 1.5 square plus 2 square and the radical. Then you can find the dimension of AB. So let us see the solution. So AB is just by Pythagoras theorem. Pythagoras theorem, you can find just Pythagoras. By Pythagoras theorem, you can find just radical 2 square plus 1.5 square, then you get 2.5. So 2.5 is the gate dimension. And next step, you can find just moment of inertia about the centroid of the gate, about the center of the gate. BH cube over 12, then you get this meter, the power of 4. Then next step, let us see area. Area of the gate is B times H, so you have 7.5 meter square. Then let us go. Tan theta is just tan inverse of 1.5 over 2. Then you get this result. Then finally, the top edge of the gate is below water surface. The top edge of the gate below water surface, you can find. This is the top. The top edge of the gate is at this point, so you can find this distance, which is y. Then I think for h, you can find 15 minus 1.5. 1.5 is the vertical distance here. You have here the vertical, so you can find total h. This is h, the height below water surface, the edge of the gate. So you have 13.5 meter. So total hydrostatic force F acting on the gate is nothing, gamma W times h bar times area. So to find h bar, you have 13.5 up to h, then what will be up to this point? So you have to add this 13.5 plus then the vertical distance from here up to here. What is that value? So you have 1.25, because 2.5, if you just have half of that, then you can find the center. So 1.25 sine of this one, then times area, you get this result. So this is the net hydrostatic force acting on the gate. So since you have 2.5 dimension, half of that will be 1.25. 1.25, 1.25, half of the gate. So you have 2.5, then you get 1.25. Then center of pressure, CP, just center of pressure from water surface, HCP, which is IG sine square theta over A times H bar plus H bar. You just follow H bar again. So you have H bar after the center of the gate, you have H bar, which is just up to the center of the gate. You have to add, then finally from water surface, you have, this is from the top water surface, 14.26 meter. Now we find the distance D where the force F acts from the hinge. So you have here, you have force, this is the force. So at what distance you can find? So D will be 1.25 minus YP minus Y bar. So you can just subtract. Then D will be 2.5 minus L, which is the slant length, where L is the distance from A to center of pressure. From A to center of pressure, if you make L distance, then you can find L. L is nothing, HCP minus 13.5. HCP, you have total HCP minus, then 13.5, this height, which is this one. Then you can find the total distance. HCP is already known. Then 14.26 minus 13.5 over 0.6, you get this distance. So this is the L distance, which is the slant length, which is from the hinge A up to, from point A up to the CP. So D will be the same. You can find this result. Once you get this one, you subtract 2.5 minus this one. This is D distance from the hinge. So take moment about B, about the hinge B. You can take moment at this point, then just summation moment at P is equal to 0. Then P times 2.5, you have P, which is perpendicular distance. So moment is the force times the perpendicular distance from the axis of rotation. So you can calculate this one. So 2.5, which is counterclockwise, then the net hydrostatic force, which is this one, times 1.233, which is the distance from the hinge up to the force, the net hydrostatic force. So you get this result. So this is just the normal force applied at A to open the gate. Then, if P is not exerting and horizontal force is acting by the smooth wall at A, you can have this free body diagram. So you have AX due to this smooth wall, you have net hydrostatic force F, then this is hinge, it will support BX and BY. Then how do you compute? So sigma moment at B, take moment about B, these forces will cancel out, then you can calculate AX, or the horizontal force acting on the smooth wall, which is just on the gate, then AX times 1.5, then you will have AX, this is just perpendicular distance, you can find up to this one, then minus 1048.44 times 1.233. This is just the distance from this up to this, which is D, calculated in the above. This is D, which is already computed. Then AX will be this one. So summation of force in X direction equal to 0. Summation of force in Y direction is equal to 0. So you will use three equilibrium equations to compute unknown values, reactions, and other. Then Bx plus, this is Bx to the right, plus this one, 1.5 over 2.5, because you have total distance, then divide by 2.5, which is sine. Then you can have, I think this is the net hydrostatic force, you can just compute. You can compute components, clear? Components in the X direction, which is cos theta. So cos theta is just opposite over just opposite, which is adjacent over hypotenuse. Then hypotenuse is 2.5. Then you can find Bx. This is Bx. Then sigma force in the y direction is equal to 0. Again, you will decompose the net hydrostatic force into components here, horizontal and vertical, then make the angle theta, then finally you get this result. So this is the reaction at point B. Okay, so this is all about today's tutorial. Hopefully you liked the video. If you have any comment or doubt regarding this topic, please let me know and write down in the comment section below. I will definitely reply on it. So please like, share this video with your friends and subscribe to my channel to get more videos on similar examples. Thank you very much for your attending.